Right now, a very large and very complicated science facility is under construction in Sweden. It's called the European Spallation Source, but usually known as just ESS. Okay, so why is this interesting? Well, it's being built to answer some of the most urgent real-world problems, like how do we build longer-lasting batteries, and how can we more effectively treat cancer? Now, these are quite tricky questions, and the way ESS will help answer them is by using a particle smaller than the atom, the neutron. Now, neutrons are fantastic particles because they interact with the world around us in a very unique way. For example, if you would shine neutrons at a glass of water, the water would appear opaque, while for light, as we all know, water is transparent. Likewise, there are other elements which are more or less invisible to light, but which can be clearly seen with neutrons. So by using neutrons, you can see and learn things which would be otherwise impossible. Unfortunately, neutrons have two huge drawbacks, which I've dedicated two boxes for here, one red and one blue. The first issue is that they are extremely difficult to produce, which is why you need these huge facilities like ESS to get them efficiently. To do this, you have to accelerate protons close to the speed of light and smash them into another nuclei. The protons will strike so hard that the nuclei shatters and neutrons are released. You can see this represented by the long red and blue arrows in the pictures. And this leads me to the second issue. So once the neutrons have been produced, steered in the right direction, and bounced off whatever you're curious about, neutrons are very hard to detect. And even more so, they're difficult to detect rapidly, one after another. And this is where my PhD project comes in. So I'm building a new fast counting neutron detector. And this is because the rate of neutrons produced at ESS will actually be the highest in the world. And current detectors cannot count neutrons that fast. So to solve this issue, we're building a sort of sandwich detector, which is built up many layers. So this spreads the neutron detection along depth of the detector, which makes it easier for it to keep up counting. So in summary, I'm building a tool to help scientists make new discoveries. Thank you.